So, any question for the class, for the homework or assignment? Let me know. Any question? Any question? Let me know.
I've been working on assignments for other classes, so I haven't done all of it yet. So none from me for now.
Okay, so if you don't have any question, let me move to the chapter 9 about the WAN connection here. So far we know that some of the types of network you have the LAN, right? It's a local area network. It only contained in a small area only. And for the WAN, it's an interconnected LAN together and it span in the wide area here. And normally you have to involve the telco, the telecommunication company here, right? It provides the transmission in order to connect the two remote LAN together here. And the WAN it go through a significant distance and usually support very high data throughput. And you have the many type of WAN. It depends on the following factor. It can be the traffic load, right? How much data you want. It can be budget. It depends on the money you invest here, right? And it can be depend on geography and the commercial available technology. And the difference between the WAN and LAN, that some of the things you need to identify the difference between the WAN and the LAN here. The first thing is that LAN connects the node, right? Interconnect the device together on the same area in a small area here. And WAN connects the network spread over the wide geographic area here. So you can think about in the normally you have a LAN here, you have the switch, right? And the switch here, you interconnect the device together, interconnect the end device together. They call it the node here. Right? That is the LAN here, and normally you have the router to route to the internet here. But the WAN is the interconnected LAN together. So you have the one LAN in one area, and you have the LAN here into the other area, and you interconnect them together. You have the WAN here. Right? So the first difference between the WAN and the LAN is the geography here. Right? LAN is only contained in small area. So normally it's a classroom or in the campus only. Right? But the WAN is interconnect LAN together. You can think about we have the campus here in the Bloomington, and you have the campus here in Indianapolis. Okay, now the second one is that the different layer 1 and 2 access method. It can be topology and media here. So normally for the WAN, you have the point-to-point connection or point-to-multi-point connection. You have the point-to-point connection that you think about from Bloomington here. You connect it to the Indianapolis branch. You have the point-to-point connection, or you can have the point-to-multi-point connection. So you have the hub here, right? You have a hub in the Indianapolis, and you can connect it to the Bloomington campus, and you can connect it to the Lafayette campus here. Right? Okay, and remember that the only difference in the layer 1 and the layer 2 access method. So how you access to the network. But from the upper of the layer 3, everything is the same. Everything is the same, right? And normally the LAN is typically a private owned, that it can be owned by your own. You can think about the home network, it's a LAN, or it can be administered by Ivy Tech campus here. That is normally it's a private owned. But when here you see normally you have to involve and operate by the telco here, and also know it's a network service provider, because you think here when we interconnect the LAN together, you have to involve the transmission here. Normally you cannot run by yourself. It's too way expensive here, right? And you cannot support for the long transmission from between the two LAN here. That's why you have to lease it. You have to rent it from the telco here, and the core is the network service provider. It can be the AT&T, it can be Verizon, or the Comcast here. Okay, so that remember that for the WAN you have to involve, right? For the WAN you have to involve the local area network, and you have to involve the transmission from the internet service provider here. So it always there is a point. It always there is a point to separate which one belong to the LAN and which one belong to the internet service provider here. And that point they call it is an entry point here. So think about if you work at the home, right? You have the home router here, right? And the home router you connect it to the internet. That also is the entry point to separate which one belongs to the network and which one belongs to the ISP here. So normally, if you work with the digital subscriber line or the cable internet service here, you connect the home router to a modem. Modem, it is a modulation and demodulation here, and normally it is convert from the digital signal to the analog signal, and from the analog signal to the digital signal. And basically, for the network here, the router is the one integrate everything. You have the modem, you have the switch, you have the access point, and everything is the router here. And they break it down into two types of the device. The first one is the data terminal equipment here, DTE. It is a customer endpoint device on the WAN. So think about your home router. It is a DTE here, right? It's a customer endpoint device on the WAN connection. And you have the data communication equipment here, DCE. It is belong to the ISP here. It is a carrier endpoint device for the WAN, and communicate to the WAN is owned by the ISP. But normally for the home connection, everything about the DTE and DCE also integrate in the router. But for the large network here, for the enterprise network, they separate between the DTE and DCE. And normally DTE is router and DCE is the one you connect it to the ISP here. And equipment normally located in the customer premises, called the CPE. That means you have the customer premises equipment here, and the demarc here, the demarc point is where the point, the carrier responsibility and the customer responsibility begin. So you only have the point, you separate which one belong to the ISP and which one belong to the local area network here. And this is the point, it's the demarc point here. It's where it clarifies which one belong to the ISP responsibility and which one belong to your own responsibility here. Okay, so we see this is the kind of the entry point equipment here. You have the DCE here, sorry, DTE here. DTE is the home router here, right? And when you connect it to the ISP, you need to involve the DCE. The DCE is the modem. It converts the digital signal from the local area network here. Right? It converts the digital signal here into the analog here. Or it can convert back from analog to digital. Right? And you have the endpoint. So you have the demarc point here. You break it down which one belong to the customer responsibility and which one belong to the ISP responsibility here. But remember, if you work from the home network, normally the DCE and DTE they integrate it into the router. Yeah. And also you have the sum of the device, the common route near the demarc point. You have the network interface units connect the ISP local loop to the customer network. You have the line driver. Normally it's a repeater here that can boost the signal across a greater distance. Right? So far, when you learn about the signal, you know something about attenuation. Right? Attenuation here. Attenuation. What do you think? What is it? Attenuation? Any idea?
Attenuation makes it long transmission, the signals get weak. And
yeah, it will degrade, right? The longer distance, you have the higher degrade of the signal here. You can think about that at the beginning here, but when you have the long run, you can have a very small signal here. Right? So in order to recover it to the original signal, normally you have to repeater here. Repeater, that means you can repeat it and it regenerate it into the original here and transmit it again on the long way here. And you have the CSUDS, it is a channel service unit, and the data service unit is served as the endpoint for a dedicated connection between the ISP and customer here. So remember that in order to connect from the LAN to the WAN, you have many ways to connect it. One of the way it is dedicated here. It's dedicated connection. That means the link is reserved it for you only. But normally for dedicated, you have to pay a lot of money, right? That even that you don't use it, you don't have any data going on, you only have to pay. It reserved it for you. Right? Otherwise, you can share with the other one here. So we can think about you have the optical cable here. In order to connect it, optical cable from the Bloomington to the Indy here. I see you might have the Indy here. Sorry, you might have a Ivy Tech Bloomington here, right? You might have a Cook Bloomington here, or you might have another company or so. All of them share the same transmission. Right? So when in the case you share, the price is lower because you share. But the thing is that if you want something about stable, right? It only reserved it for you, and you want something about security, you have to do with the dedicated connection. Dedicated connection, that means it only connected to you, not shared to anyone here.
Single private line.
Yeah. Okay, so now you move to the routing protocol. So remember that I already mentioned about the router. Router is a layer 3 device. Right? It understands everything about the IP address here. Right? So see, in the case you want to deliver, in the case you want to deliver the packet from the source to the destination here. So basically, you have a long way to go from the source to destination. Right? The first step always the default gateway here. It's the router, it's the local router connected to it, right? And you can go on the way to many routers here, right? And go to the destination here. So router here, you have the two major functions of the router. You have the two major functions. The first one is interconnect network together. That remember that it interconnect network together. So whenever you want to send the packet beyond the local network, you only have to involve the router here, because the router is only the router interconnect the network together. Switch cannot do it. Switch only connect device on the same network only. Right? So whenever you want to go beyond the network, you only have to involve the router. Router is interconnect network together. That is the first function here. The second one here, it only tell you which is the best way to reach the destination. As you think about, if you have from the source to destination here, actually you can have many ways. Right? You can think about this one. You can go on this way and go on this way and go on this way, or you can go on the router here and go back to this one and go on this way. The same with you can think about when you open the Google Map, right? If you want to travel from here to the Indianapolis, you might have many ways. It can be go on the 69 or the other way here. But the router is always, it maintains everything about the database. So we know that in order to deliver to destination here, it only tell you which way is the best way to reach the destination here. And that one is changeable, right? So think about this one here. Normally this one is the bad way. Here. But what happens if the link going down, or you have the congestion here? You do everything again, right? You have the internet over here, and you route it on this way here. Okay, so remember about the two major functions of the router. The first one interconnects network together. The second one is always tell you which way is best way to reach the destination here. And the definition about what is the best way, I'll talk about later. Right? How can you define the best way? I'll talk about it later. Okay, so you see it interconnects the network together, right? Interprets the layer 3 and layer 4 address and determine what is the best path for the data to follow from the point A to point B and reroute traffic. In some case, if you have the link going down or have a congestion here, it can only have the alternative part here. And the router also may perform some of the following optional functions. The first one is the filter the broadcast transmission. You know for that, right? That is one of the reasons. That is one of the reasons why you break it down in the segmentation. You can think about here. In the last class, right? You have the network of 400 computer here, right? You see, whenever we send broadcast, all the remaining 399 have to accept it. So slow down the network performance, right? Consume a lot of bandwidth here. So for that reason here, you break it down into two networks. You have 200 here and you have 200 here. And you interconnect them by the router. You see, the router interconnect the network together, right? So this network here is one network, and this one network here is one network. And you see, the router is the one who stops the broadcast message. So see, if anyone from this one here send out the broadcast message, only 199 from here have to handle and receive it. But it's not impact to the 200 here. Right? That is one of the benefits why you break it down in the network here. And the reason is that the router is the one who able to filter broadcast transmission. So whenever we send the broadcast message to the router is the one who stop it. Right? And it can prevent a certain type of traffic from getting a network. It is about the security something here, right? You can think about here, right? So normally, think about this example here. So think about you have the one network here. You interconnect them together by multiple computer here, and you connect it to router, and you connect it to the other network here. And this network, think about you have the server here. So for this one, basically that if you don't configure about the access list here, everyone able to able to access to the server here. Everyone able to access the server here. But from the router here, you have the option. You can filter. The filter you can allow it or deny it. You can configure on the switch. On the router here. So think about you can accept the traffic from this computer to access the server. You can accept this one from this computer to the server, but you can deny this one, and you are able to configure it on the router by the access list. And we'll do with the access list later on this class.
So it goes to layer 3. It goes to layer 3 with router.
You have to go to router. Yeah. The router is the one who able to filter the traffic because it understands about the IP address.
It's about layer 3.
Yeah, it's layer 3, and sometimes it's layer 4 also. Yeah. It understands that you can configure it based on the first thing here. When you configure on the access list, the router understands two things here. The first one is IP address. Sorry. IP address. The IP address here is the layer 3, and sometimes you are able to configure based on the port number also. The port number is the layer 4 transport here. So we think about this one here. You want to restrict the computer here to access server, right? You want to restrict the computer access server. You can do based on the IP address. That's the first option. Or if you want to specify that you want to restrict the IP, you want to restrict access from this IP for the web service only, So in that case, you can configure based on the IP address and the port number HC here. So anything come from the IP address here with access to the HTTP message, access to the HTTP web service, you can deny it here or allow it here. Right? So basically for the access list in the router, it understands both of the layer 3 and layer 4 here. Okay, so now filter the broadcast transmission. It can prevent a certain type of traffic from getting to a network, support the simultaneous local and remote connectivity, provide a high network fault tolerance. So in the case the link going down, you have you can reroute to the other one here. You can monitor the traffic and respond static, and diagnose the internal and other connectivity problem and trigger alarm whenever you have the alarm here. Okay, and in the router category, normally it break it down in the 3 category here. The first one, the core router. The core router or the core is the interior router. It's the direct data between the network between the same autonomous system. You have the definition of an autonomous system here. Autonomous system, you can think about the autonomous system. It is about how can I tell? About each of the corporate here. So we can think about the AT&T, right? They have specific autonomous system and it's unique. You cannot never ever have that one. Or you can have the Comcast also. You have this is autonomous system. So the core router, it is the one who direct data inside the autonomous system of it, right? So think about the AT&T here, it's only inside the network of AT&T, and about the Comcast here, inside the network of the Comcast here. The second one is edge router or border router. Border router is the interconnect from the two autonomous system together, right? So in the case that you want to connect from the AT&T to the Comcast, you have to involve the edge router here. And remember, the edge router is the one who belongs to more than one autonomous system, right? You see, when you interconnect them together, right? So one interface here, you belong to the AT&T, and another interface here, you belong to the Comcast. Yeah. And the exterior router, it refers to any router outside of the organization of the autonomous system here, and it directs the traffic between the autonomous system here. Okay, so we can think about this one here. If you look on this one here, you can see this one is an autonomous system here, and this one is an autonomous system. Right? So that is a core router here. Core router is totally inside the autonomous system and reroute every traffic inside the autonomous system here. And you have edge router here. Edge router, it is belong to the more than one autonomous system. Right? You see, you have the connect to the autonomous system here, and you connect to the ISP here. That is edge router, and this here totally it is an interior router. Now, so we talk about that the router is only tell you, the router only tell you which way is the best way to reach that station, right? And the reason that it able to tell you because it maintain about the routing table here. It maintain about the routing table. Oh, what's this? It maintains about routing table. So that you remember about when you work with the street, right? So that remember the street here. You connect the street to the computer, and you connect the street to computer here. So when you want to send the frame from this computer to the another computer, you forward to the street, right? And how can street know that? How can the street know that it forward it to the correct port instead of this not this port here? What do you think?
MAC address. ARP routes table.
The MAC address table. The MAC address table. And remember that a MAC address table is a layer 2 only. It only matching between the MAC address and the port number. You see, it only idea about the MAC address and port number. You have no idea what is the IP address here. So that is in case of the MAC address table for the local network. But in the case of the router here, it maintains about the routing table. So maintain the routing table. So what you have inside the routing table, you have the destination network here. You see, you have the destination network here, and you have the subnet mask of the network here, and it tell you here. It tell you which way is the best way to reach the destination, to reach the network destination here. It only tell you which way is the right way, and in order to tell you which way is the best way, it maintains about the routing metric here. So the higher metric is a not good part here, but the lower is the better one here. Remember that. Think about this one here. Think about the simple routing protocol. It's a RIP here. It's routing information protocol. RIP is totally based on the hop count only. So think about this one here. If you want to send from the LAN area here, you send it to from the computer here in the LAN area, you want to send it to the LAN D here. So you see, you send it to the router here, and router, you have the two way to go to the destination. You can have go on this way, go to destination, or you can go on this way, and this way, you go to destination here. So the RIP is totally about the hop count. So think about this one here. When you send from A to the D by this way, right? By this way here, you have one hop. You have two hop here. So the magic here, it put it here. 2. But on this way here, you see, 1, 2, 3, right? This way, 3 here. So The router knows that you have the two way to route to destination, right? But it updates in the routing table about the best way only. Right? That's why it take about the number 2 here. So any traffic you route it from the LAN A, you send it to the router and send it to the router C and go to the destination. And of course, if something is going down with this one, the router is smart enough to bring it back to the link here and route it on this route here. Right? And remember, the RIP here is only very simple routing protocol, and nowadays normally only work in the lab only. It never work in the real environment here. The reason is what happened here. What happened is the link here is only support for 64 kilobit here, right? But this link here support for 1 gigabit and 1 gigabit here. But when you work with the RIP only care about the hop count, right? So it only send it to the 64 here. It's not good at all. It's not good at all. So normally the RIP here is only work in the lab, but no, on the real life, it never ever used here. Okay, so remember that in order to deliver to destination here, the router always maintain the routing table, and the routing table in the routing table, you see, in the routing table you always have the destination network destination here, right? And it always tell you which is the best way to reach a destination here. So we can tell you that in order to reach a destination, you have to forward it to the router C, and you have to forward out the interface here. Right? You see, you have the gateway and you have interface here, and also tell you what is the magic here. Right? Magic here. How much you have to pay in order to reach a destination. You can think about the magic is how much you have to pay. Right? That's why the more you have to pay, the worse quantity, right? The worse quantity, and the lower you have to pay, the better quantity. Okay, so remember that in order to the router always tell you which way is the best way to reach the destination here, right? And it maintain about the routing table here. But how can the router update information in the routing table? Right? You see, when you power on the router, you have nothing, right? You have nothing here. So how can the router update information in the routing table? You have to answer it here. So if you remember about the switch, switch maintain about the MAC address table here, right? And again the same, the switch here when you power on, you have nothing. So how can switch update in the MAC address table? Let me check your understanding again here. Broadcast. How the switch update the MAC address table? Anyone?
Doesn't it learn from traffic traveling through it?
Yeah, right. It only learn from incoming traffic. Right? For the switch here, it only learn from incoming traffic. You think about this one here. If you have the switch, right? If you have the switch here, you have a port F0/1 here, right? And you have port F0/2 here, and you connect it to the computer with the MAC address A here, and you connect it to the computer with the MAC address B here, right? So at the beginning, you have nothing in the MAC address table, right? Now, if you want to send the frame from computer A to B, you have to send it to the port F0/1 here. Right? Should learn it from incoming traffic. Right? So see, he read in the frame, he knows that the source MAC address here A, right? So he update A, and he knows that it coming from the port F0/1. Now he update in the F0/1. That's the MAC address. It only learn from the incoming traffic here. Okay. Now we come back with the router. You see the same. The router at the beginning, you have nothing in the routing table. You have nothing in the routing table here. Right? So, and in order to tell which way is the best way to reach a destination, it only have information about the destination here of the network subnet mark here. Right? Now you have to figure out how the router updates the routing table here. Right? So normally you have the two way to do that. The router have the two way to do that. The first one is static routing. The first one is static routing. It is a network administrator. As a network administrator here, you have to configure the routing table to direct the message along the specific packet. I think about this one here. You have the first one is manually static here. So we think about you have the computer here, and you connect to the router, router 1 here, and you connect to the router 2 here, and you connect it to router 3, and you go to destination here. or you can have the router 1 to the router 3 here. Right? So now, if you work with the static route here, if you work with static route, right, you have to configure it manually. You have to go to router 1 here, and you tell that if you want to reach, think about if you want to reach to the one network here, 192.168.1.0/24 here. You have to configure it. If you want to reach to the 192.168.1.0/24, you have to route to the router 3 here. Okay, that's the manual. That is static. You have to configure on the router 1 here. You have to do it manually by if you are the network administrator here. Now, what happened here? Is this link going down? What do you think? What happened? No, you cannot do it. The router, let's see, the router is have no way to do it here, right? Because if you want to do it again, if you are an administrator, you have to configure it again. Right? If the link is going down, you have to configure again. You tell the router here, 192 here, 168 here, .1.0. Now you have to send it to the router 2 here. Right? So you see, that is a huge problem of static routing here. It's not automatically shift. Yeah, it's not automatically shift in the case of the link going down here. If you are the administrator, you have to go to the router and you have to configure it here. Right? That is the first problem here. Now think about this one. If you send it to the router 2 here, right? If you send the router 2 again, again the router 2 also you have to configure here. You tell that if you want to send 192.168.1.0, you have to send it to router 3 here. You see, you have a lot of work with the static here. Huh? And again, also when you reach the destination here, what happened? If the destination want to reply, here again, you also have to tell router here how can you route to the, think about this one, 10.10.10.0 here. Also, you have to configure it here. So now, if you route to the 10.10.10.0, you have to send it to router 2 here. And again, you also have to configure it. Right? So see, for the static route here, you as a network administrator, you have a lot of work to do it. You have to manually to do it here. Right? So basically here, normally for static route here, it only works for small network only. It only works in the small network. You see, if you have many routers here and you have many ways here, you cannot go to every router and manually configure the route here. And what happens if there's something link going down, you also have to manually go to reconfigure it again. It makes sense?
I get it.
Okay, so for that reason here, static routing or the manual routing here, it only works in the small network. Okay, it only works in small network. That's the first thing you have to remember, that it only works in a small network here. And normally you can think about the home router here, right? You can think about the home router here. You only have, in the home router here, you only have one router, right? And the network here. You have to switch. You connect it to multiple computers on the network here. That is a home router, right? And you see, from home router here, you only have one connection to the ISP, right? You only have one connection to ISP here. So that is the case you configure the static here. Right? You see, I only have one way here. I don't care. It's always that way. So it's going down. I have to accept it. Right? I have to accept it here. That's why that is the case that it only configures the manual route, static route in the small network only. In the small network only. All right. Okay. And of course, everything has the two sides here. All right. This one here, it works in the small network, but also it has some benefit here. Some of the benefit here. The first thing is that when you configure manually here, you know for sure it only goes on this route. Right? If something going down, you know for sure you have to take the action to investigate it. The first one, you always know for sure which is the route you route to the destination here. Right? That's the first one. The second one is that very important here. Right? Now let me come back. Sorry, I can come back it later. Now we move to the dynamic routing. The first one static, you have to manually configure. The second one is dynamic. Dynamic is that means they exchange information together. the router exchange information here. They advertise together here. I think about this one here. You have the router, you connect it to the network here. You connect it to the other network here. You can think about this one 10.10.1.0. And you have network here 10.10.2.0 here. And you interconnect the two routers together. And this one we have two network here. So for this network, you have 20.20.1.0, and you have the other network here. You have the 20.20.2.0 here. Okay. So in the case of dynamic routing here, you configure the dynamic routing. Every router, right? Router 1 and router 2 here, they exchange information together. They advertise information and they learn it from each other here. So think about this one here. Router 1 here, he have the two, actually he have the three here, right? He have the two directly connected network here because it directly connected to him, right? So we see, I explained it, I think I explained it on this class already. So whenever you have the interconnected network here, it automatically show up on the routing table. Automatically show up in the routing table here. So now you can think about this one, G0/0 here, right? And you have G0/1 here. That's why when you show IP route, it only show up on the routing table. And you know that from router 1 point of view, you know that if you want to route to the 10.10.1.0 network, send it to me on G0/0. He have updated, automatically update his routing table. Now, for this one also, he update here. You have 10.10.2.0. Send it to me. I send it to the G0/1 here. It directly connected the network here. So now he advertise to the router 2. He tell the router 2 here, hey, if you want to send to the 10.10.1.0, please send it to me. Please send it to me. He tell information here. And if you want to send to the 10.10.2.0, again, send it to me. So see what happened here. The router 2 learn it and update from the advertisement from this one here, right? Of course, in the router 2 also, he already have the two directly connected network here. So he updated here 20.20.1.0, send it out of the G0/0 here and G0/1 here. He send it out to G0/0, right? And you have network 10.20.20.2.0 here, send it to G0/1 here. They are directly connected network. And now you learn from remote network here. You learn it from remote network. This one here, this network here, not directly connected to the router 2. And you learn it from the advertisement from router 1. And now he updated here. Now I know that if I want to send to 10.10.1.0, I send it to the router 1. And I send it out from the 0/0/0 here. So now I know that I want to send it to 0/0/0. And again, I update also this one also, right? I update it here. 10.10.2.0, send it to the S0/0/1/0 here, send it to the router 1. That is a dynamic routing. That's a dynamic routing here. And again, this guy also, he advertised, right? He advertised to the router 1 that I have two network here. So if you want to send the 10.20.1.0, send it to me. If you want to send the 20.20.2.0, send it to me, right? So now this guy also updated here. So when every router learn from each other, they build up the routing table, right? And then have every network of the destination here, a rigid destination here. So in that setup, they call it the conversion here. Conversion, that means you already update the routing table and you learn it from every destination here. Okay? So see, you learn it from each other. You always learn it from each other. So think about here. If you have another router here also, right? You have another router here, and you have two networks here also. They update it. They update in the routing table here. So now see, if this is going down, right? You know for sure here can send it to the router 3 here. So that is the benefit of dynamic routing here. So dynamic routing, you always learn it from each other. It's the exchange information together here and learn it and update in the routing table here. And if something going down, it automatically shift to the alternative path here. You don't have to do anything. When you compare to static route, you have to manually configure here. But in the case of dynamic routing, it automatically shift to the alternative path here. You don't have to do anything. Okay? So now the question here, so see the dynamic routing, you have a lot of benefits. Why don't you use a why don't you use a dynamic instead of static here? What do you think? What do you think? Any idea? It says the dynamic routing here, you have a lot of benefits. The automatic exchange together, update it in the routing table, and automatically shift to the alternative path here. Why don't you use the dynamic routing instead of static routing? What do you think?
Static is more stable because it's fixed. More stable.
Why is it more stable?
If I just have the one IP as an ID, I don't have to switch every time. So maybe it's easy to reach. Or
Yeah, of course, it's easy to reach here.
He don't always change the IP address.
No, nothing changed here. Nothing changed here.
Oh.
The thing is, see, look. And hello.
Would static be more secure than dynamic?
It's also one benefit. You know why it's more secure? You know why it's more secure here? Why?
I imagine if it's automatically trying to find routers to go through, it could possibly travel through a router set up by a malicious actor if it's dynamic.
Okay, yeah. The reason it's more secure here. The reason it's more secure. Because you see, in static route, you don't have to exchange information together. Right? You don't have to exchange the configuration here. You don't have to exchange the routing table together. You don't have to exchange, right? But in the dynamic here, you see, in order to build up the routing table here, you have to exchange information together. Right? You see, if someone here he able to capture what's going on with the network, he can do the bad action here. Right? That is the benefit of the static route here. More secure. Right? More secure. And of course, the first one you only know for sure which way is the way to the destination here. Right? We call it manually static. Anything else? What do you think? Anything else? Anything else? Anything else? Think about that. Think about that one. When you exchange information together, right? When you exchange information together, you have message going on, right? You consume the bandwidth here. Yeah, you consume the bandwidth here, right? So that's also the static here. You don't have to exchange here, right? That's why you reserve the bandwidth. And the third one here, you see, you only have to maintain about the routing table. So you have consumed about the memory in order to buffer for the information here, right? And you have to take action here to compute everything if something going up and down, right? So that is some problem with the dynamic routing here. And when you compare to static route, right? So see, normally for the static route here, if you have the small network and you are able to know to configure static route, you should do it. You have more secure, right? Do not consume the bandwidth here, and you don't have to consume anything about the memory, about processing here. Right? This one here, you have to exchange a lot, and you have to maintain about the routing table here. If link are going up or down, going up and down, you have to take a lot to process it here. Okay, make sense?
Yeah, I think so.
Okay, now for the root, the utility allow you to view the whole routing table in the window or the Linux console, right? The root command also will be used to add or delete the static root here. So basically, you see, for every computer, right, you only have the static root, how to route to the default gateway. Huh? That is the way you want to remote the network. You have the route to the default gateway here. And in the Linux or the Unix, you can use the root here in the Windows-based system. Use the command root print, and on the Cisco iOS here, the command is show IP router. It's so yeah. Okay, so in the case you work with a Cisco device, if you want to show the routing table, you go to the previous port here and show IP route here. Okay, so see, it tell you, right? Tell you here, right? Basically for this network, very simple. You don't have remote network. You only have the two directly connected network, right? And you see on the top topology here. If you see on the topology, you have the two network here. Each interface of the router is one network, and you have another network here. So that's why you see. That's why when you show IP route here, you see you have the 2C here. 2C, that means you have two directly connected network here. See here and see here. The one network is the 172.31.0.1/24, and the second one is the 192.168.1.0 here. So you see from this computer here, right? If he want to send to anyone in the network 192.168.1.0, he send it to the default gateway, right? And the router here, he look it up in the routing table, and he knows that, oh, if he want to reach to any computer in the 192.168.1.0, he had to send it to the G0/0. So now he just forward it to the G0/0. Okay, that is very simple of the network here. That's why you only have a two directly connected network here. But anyway, it works with the routing table. Whenever we send to the default gateway to the router look it up in the routing table, right? And see what is the destination IP address here. Destination IP address belong to the network 192.168.1 here, and just route it out of the G0/0 here, and he route it to the interface here. So when you come to the switch knows that if you want to send to the .10, he had to forward it out of the F0/1 here. It makes sense.
Yeah, it does.
Okay, now you know that the router only tell you which way is the best way to reach that destination, right? And in order to tell which way is the best way to reach that destination here, it works based on the routing magic. It works based on the routing magic. I can think about the routing magic. It is how much? How much? Think about that, right? So the lower one is the better one. Right? The lower one is the better one. That's the thing about if you have the thing about this one here. You have the sort here, and you go to that destination here, and you can go on this way. You can go on this way. This way is only you have to pay for 10 only. But you can go on this way, and this way you have to pay for 20. So the lower one is better. This is the better one here. That is the routing magic. Routing magic. That is a number to tell you how much you have to pay in order to reach from the source to the destination here. And remember, the lower one is the better part here. Okay. That's the first definition, the first thing you have to understand here. Now, the routing magic is a property of the route issued by the router to determine the best path to the destination here, and it can work based on hop count. I give you example already, right? Hop count here, and it can be work with the bandwidth and throughput, and work with the delay and latency of the potential path. It work with the load and traffic or processing burden here. It has the maximum transmission unit or the largest IP packet size in the byte allowed without the fragmentation here. Okay, and the routing cost or the value assigned to the particular routes and reliability of the potential path and topology of network. Now, the routing magic here, it is how much you have to pay in order to reach from the source to the destination. And in order to figure out how much you have to pay, it depends on they call it the routing protocol. Routing protocol here. It's called routing protocol. So you have many types of routing protocol, and each of them they have the different way to figure out how is the routing magic here. So think about the hop count here. The hop count it is work everything with the RIP. routing information protocol. It's totally based on hop-cow. Right? Think about if you look it back on my example here, you have the source, right? You send it to the router 1 here, and you send it to the destination here. Right? Destination here, or you can send it to the router 2 and send it to router 3 and destination here. I see the hop cow work with the RIP. RIP is totally work only with the hop cow, right? So we see this one is bad way. This one here, the magic here, the routing magic here, number 1. This one, number 2 here. So the RIP here, he doesn't care everything about the bandwidth or delay or latency. He doesn't care. So we see if this one here, you have the hop-cow one, but it only support for 64 kilobits per second. But this one here, if you can support for 10 gigabit per second here, definitely this way is way better here. Right? But when you work with RIP, you have no idea about that. You only care about the hop-cow. That's why RIP here is only work in the lab environment. It not work in the real life now. Right? And you can work with the bandwidth here and actual throughput. Everything they work with the OSPF here. OSPF is an open sorted platform. It also routing protocol. When I talk about this one here, this one is one type of routing protocol. This one is another type of routing protocol here. So for the OSPF here, it works with the bandwidth and throughput. Right? So you figure out in order to reach from the source to destination here, how much you have to pay. Right? So for this one here, normally he have a reference here, 10 gigabit here. 10 gigabit is the reference, right? So we see you have the 64 here, you divide for the 64. So for this one, you have to pay about 150, right? 150 for this route here, right? And for this one here, 10 gigabit here, you only have to pay for 1 for this one. Right? So see this one here. So we have 1 for this one and 1 for this one. When you add them up together for this one, you only have to pay for 2. But this one here, you have to pay for 150. Right? So that's why when you work with the OSPF, this one is a better way here. So in order to figure out the routing magic here, it totally depends on what type of routing protocol you use. Right? Some of you can use the hop-cow, it's a RIP. You can use with the throughput, or you can use the delay, latency, and the traffic load. You have to work with EIGRP here, IGRP. It also is a routing protocol. It makes sense?
In matrix, they consider the 9 elements together. So which one you want to use or priority?
You have the 1, 2, 3, 4, 5, 6, 7, and 9, right? You have the 9 what is it?
Factor.
Yeah, 9 factor here, right? You have 9 factor here, and it depends on what type of routing protocol
you want to use.
What type of routing protocol? Some of them they use only for hop-cow. You don't care about anything, right? That is you work with the RIP here. RIP here, he only care about this. Sorry, the RIP here, he only care about hop-cow, right? They only care about hop-cow. And some of them they use a combination. They use the combination of the sum of the factor here. So think about in the case of OSPF here, it care about the bandwidth and the throughput here. Right? But some of them you can combine some of the factor if you work with EIGRP here. You have to work with the delay, latency, and the load here. Right? Not always all of them factor in the routing protocol, right? So for each of routing protocol, they have the different way to figure out what is the routing magic. Okay.
You choose several factors, not all.
Yeah, not all. Yeah, and it depends on which routing protocol here, right? Okay, so now routing protocol. Now it always determines the bad path, right? And in order to determine the bad path, it maintains about routing magic. Right? The higher you pay, the worse pay as the worst part it is. The lower you have to pay, the better part it is. Right? So the routing protocol is used by the router to communicate with each other to determine the bad path here. So you see, in the case from the source to the destination here, right? You have a long way. You have router 1, and you have router 2, and you have router 3, and go to destination here. you always have to exchange together, right? So we can think about the first one here. I have to pay for 1. The second one I have to pay for 2, and the third one I have to pay for 3, and the fourth one I have to pay for 4. You add them up together. You have the idea of how you can route it to the destination here. So in this case, you see, in order to reach the destination here, you have to pay for 9 here, right? And you see, you only have to exchange all of the router along the way, and you add them up together to figure out what is the routing magic here. You have to pay. Right? Now, the router rate, the reliability and priority of the routing protocol database on this criteria here. The first one, administrative distance here. That is very important. This is very important here. Now, you can think about this one here. Right? On the router, you can think about on the router here. On the same router. On the one router, you can configure for multiple routing protocol. Right? Not only one. You can configure about RIP here. Right? You can configure about the EIGRP here. And you can configure about OSPF here. Okay. So see, for each routing protocol, they have specific criteria to figure out what is the best way to reach the destination, right? You see about this one here. If you work in RIP here, might be this interface is the best way. Huh? You wrote it on this interface is the best way to reach the destination here. But if you work in EIGRP, might be this interface here is the better way. Or if you work with OSPF here, might be this interface is the better way here, right? You see, you have the different routing protocol, and each routing protocol you have the different routing magic, and it can tell you that for the RIP, this one is the better way. For the OSPF, this one is better way, and for EIGRP here, this one is better way. Agree or not? Huh?
I get
Now,
it.
you can come back to my previous example here, right? You see, you have the sort here, you have destination here, right? So now you see, if you work with the RIP, right? You work the RIP here, you know that in the RIP here, this is the better way, right? Because you only have the 2 count for this one, pop count, right? But what happened here? You have on this way and you put on this way here, right? If you work with OSPF and this one 64 kilobit, but this one 1 gigabit. OSPF, this way is the better way. Right? So you see, it depends on routing protocol. So each routing protocol tell you which is the best way to reach the destination here. So you see, for RIP, it might be this way, but for the EIGRP, it might be this way, or the OSPF here, it might be this way. Right? So in the case that you have many choice here, right? They have to work with the administrative distance here. This is the one who tell you which is the winner. Which one is the winner here, right? And the administrative distance here, they work with specific routing protocol. Each routing protocol, you have specific administrative distance here. So you can think about the RIP here. You have 120 for this one. Administrative distance here. EIGRP here, you have the 90 for this one. And OSPF here, you have 110 for this one. And when you work with the administrative distance here, the lower one is the winner. So see, when you, at the one time you have the 3 of the routing protocol here, but this one here is the lowest one. It's the winner. So the router, it determines that it is the best way to reach that destination. Make sense?
Yes, that makes more sense. Thank you.
Yeah. So the first definition, remember that administrative distance here, the lower one is the winner. You just remember that, right? And it depends on what type of routing protocol. Each of them, they have specific administrative distance here. The second one is the conversion time. Conversion time is the time it takes to recognize the bad path in the event of change or the network outage. We think about in the case of dynamic routing, right? You always learn it from each other. You always listen for the status of the way from the source to destination here, right? So if something going wrong or going up or down, you always have to update it, right? And you have to do a lot of computation again, and you have to determine what is the best way to pass here. That is the time of the conversion time. If anything going up or down or any change in the path here, you have to take time to do everything about the computation again, and you have to giving out the conclusion what is the best way to reach the destination here. Also, the third one is overhead here. Overhead is a burden placed on the underlying network to support protocol. You see that in order to maintain the routing table, you only have exchange information together. Right? In the exchange information together here, you have the IP packets, and of course you have the overhead here. Right? Overhead about the information, control information here. Right? And this also, if you have too much information about overhead, it slow out the process here, consume the bandwidth here. Right? Okay, anything? Anyway, this I think about the definition only, but I hope you understand it. Now you have to break it down into two type protocol. You have the interior and exterior gateway protocol here. And interior gateway protocol is a protocol inside the autonomous system. Inside the autonomous system, and the exterior gateway is the protocol you when you interconnect to other autonomous system here. When normally you use the edge router, right? The router is interconnect between the two autonomous system, and the interior gateway is a way you inside the autonomous system here. Again, in the interior gateway protocol, it breaks it down into two type protocol here. You have the distance vector protocol, and you have link state routing protocol here. So normally for the distance vector protocol here, it calculates part on the basic of distance to the destination. So think about this one here. All right, you see, if you want to send from the source, you have to send it to the router 1. You have to send it to router 2. I have to send it to the destination here. Destination here. Or you can again send from the router 1 to router 3, and send back to router 2 here, and send to destination here. Now, in the case of the distance vector routing protocol here, it only calculates the basic of the distance to the destination here. I think by this one, if you want to send from the source to destination here, you have one hop count here. Sorry, you have two hop count, 1 and 2 here. So from the router 1 here, it tells that you have number 2. In order to reach the destination here, you have to pay 2. In the case of RIP here, you have to pay for 2, but for this one, you have to pay for 3. So this one is the bad way. In the case of RIP. So he updates in the routing table here. He knows that in order to reach the destination, you have to pay for 2 here. And he only cares about the distance to the destination. That's all. He cares about the distance here. And he has no idea of the overview of the network. You have no idea of the overview network here. So that is a huge problem with the distance vector routing protocol here. It takes a long time. It takes a long time to call the conversion here, right? Because you have no overview of the topology network, right? So it's something going down here. You have to do. You have to figure out what is the best way again, and it takes a long time for you to conversion, right? But in the case of link state routing protocol here, it enables router to communicate beyond the neighbor router in order to independent map of the network and determine the best path. In the case of distance vector here, every router on the network, he has overview of the topology of the network. So you think that this one is very simple here. Let me do it again here. This one is very simple. You think about this one. Yeah, you have the better vision here. I think I have this one. Yeah, and no, I don't have it. So how can it let me do it here? You have the sort here. You have send to router 1, send to router 2, send to router 3, and send to router 4, and send it to destination here. Or you can have router 1, you send to another router here, send to another router here, and send to destination here, router this one, and send to destination here. So in the case of distance vector here, in the case of distance vector, the router 1 here only know about the neighbor. He knows that in order to deliver from the source to destination, you have to send it to the neighbor here. And the magic here, in order to reach the destination in the file. That is all he knows. He have no idea about the other router on the way. Right? He only know about the neighbor only. That is listen better. He have no idea of overview of the topology. Right? So that's why I see in some case that in the case of the if you have the loop in the routing here, right? So see that from router 1, he knows that in order to reach that destination here, he have to send to the router 2. But if you have a looping problem here, right? Router 2 again tell the source that if you want to deliver to that destination, you have send back to router 1. And you see, it looping forever here. It looping forever. That is the problem of the RIP. And of course, they have the mechanism to mitigate this one. Right? So when you have the hop count greater than 16, the bracket will be dropped here. But that is a problem of the distance vector because he have no idea of overview of the topology network. So see, from router 1, he knows that he sent it to router 2, but actually, if you have the better overview of topology network here, router 2 understands that you have no way to route it back to the router 1. Right? He knows that this one is actually loop here instead of sending it to see. Right? That is a huge problem with the distance vector here. He have no idea of overview of the network. But when you compare to the link state that each computer here, he have the map of every route on the network here. So we know that he sent to router 2 here, right? And router 2 knows that in order to do that, he have to go to the router 3 here, never ever send it back to router 1. Because he have the map here, he have overview of the map here. And in the case, yes.
I have a question.
Yes.
Might have missed it, but how do the protocols that have the overview, where do they get that overview of the routers from?
It learn it from neighbor. It exchange information together from neighbor here. Right? It exchange information to neighbor, from the neighbor here. So you see, it figured out, think about this one here, the router here. I think about this one. Oh. You can think about the router here, right? The router here. He learned it from the neighbor. He learned it from neighbor. He learned it from neighbor. Right? He learned it from neighbor here. So at the end, everyone is always learn from neighbor. So this guy here, he knows that if you deliver to this guy here, he knows that's the first step you have to send to this one, right? And again, from this one here, you have to send it to another one, and you have to send it to another one. You have to send it another one, and send it another one, and send it another one here. He maintained every router on the network in the routing table. Sorry, not on the table, in the database. He learned everything router along the way from the source to destination here on the way. That's why you have the better overview, right? But in the case of distance here, you only care about the neighbor. You have no idea what's coming next on the way here. It makes sense?
Yes, thank you for answering my question.
Okay, so just remember, again, I have to tell you that for this class is that you suppose you know everything, but not everything in the detail here, right? So I just want to explain in the server routing that the difference between the distance vector and the link state here. The distance vector, that's why they call it about the protocol of rumor. That means you heard it from the neighbor, right? You heard it from neighbor. That's all. And if something going loop forever, you don't know it because you have no overview map from the source to destination here. This one here, it maintains the map, right? You think about this one here. For the router here, you know that in order to destination here, you have 3 way, right? 1 way, 2 way, and 3 way. So what happened here? Link going down. He instantly knows that what is the best way here to the destination here, right? That's why the time it works very fast in the case of the link state routing protocol here. Because it have overview of the map from the source to destination here. Right? This one here, this guy here, only he heard from the neighbor. And what happened here? You have to loop it again and again. You have no idea about that. Make sense?
Yeah.
Okay. And of course, This one is simple, right? This one is simple and it consumes less memory here. It's very simple, only the magic. But this one here, you have to maintain about database. You have to maintain about database of every router on the network here. Right? That's why it consumes more, but it consumes more memory, and you have to do a lot of computation here. Okay, so now that summary of the some common routing protocol, right? You have some of them. They are IGP here. IGP, that means interior gateway protocol inside the autonomous system, right? You can have RIP here, RIP everything about the hop count, right? That is distant vector. That's why it's a hop count. You only know about the magic. You have no idea about the topology network here. You have RIP and you have RIP version 2. You have OFPF here. So about the link state here. Link state, that means you have overview of the network here. You have the ISIS and you have EIGP. EIGP, it is a hybrid. It's advanced distant vector. It's a hybrid between the distant vector and the link state here. And in order to route between the autonomous system, you have to use the BGP protocol here, and it is a interior gateway protocol, and it's used advanced distant vector or path vector here. Okay, now open sorted password is OSPF. I mentioned it. It is interior gateway and it is link state protocol. Link state, that means you maintain about the overview of the network here, topology of network here. Used on the interior or the border router. Normally support for large network. It support for large network because it learns everything from neighbor and build up the topology table and determine which way is the best way. Yeah. And use a complex algorithm here in order to figure out what is the best way to read that destination here. Share the data, right? So we see everyone share the routing table together. Everyone shares the routing table together and learn it from each other here, right? So we share together here. It maintains the database for of other routing link, low overhead, fast conversion here. It's very important here. The fast conversion. It's fast conversion. That means you see, you only maintain about the topology table, right? So see, when going low, something going down, you know for sure what is the next backward here. That's why it works very fast conversion here. But it demands more memory and CPU power, right? Because you have to maintain a lot of information here. You have to consume a lot of memory, and you have to do a lot of computation here. That's why also consume about CPU power for calculation here. But it keeps the network bandwidth a minimum and provides a very fast conversion time. That is very huge benefit of the open set sorted password here. Stability, use an algorithm that prevents the looping loop. But in the case of distant vector here, you see, you might have this looping here, right? And it's a multi-vendor router. That means it's support for any vendor. Can be work with a Cisco or HP or whatever it is. Now we have the IS also. It is the interior gateway protocol, and also link state protocol here. It uses a backpath algorithm. It's quite similar to the OSPF, and it designed for its use on the core router only. It's core. Remember that OSPF you can use on the edge router also, but this one only is the core router only. The third one is EIGP. It enhanced interior gateway routing protocol. It is advanced distant vector. Sometimes they call it the hybrid between the distant vector and the link state here. And it combines some feature of link state protocol. It often refers to the hybrid protocol here, right? Hybrid here. Hybrid kit because it is distant vector and some feature of the link state protocol here. Offer fast conversion time and low network overhead. It's easier to configure and less CPU intensive than OSPF. Where you have a lot of memory you have to consume here, and support for multiple protocol and limit unnecessary to network traffic between router. Normally, originally, it only support for the Cisco router, vendor, but nowadays it can support for the many vendors. Okay, now the only protocol support for exterior gateway protocol, it is a border gateway protocol. It is a EGP here. It's only one EGP here. Right? And it spans multiple autonomous system, and you can use a path vector routing protocol, efficient and customizable here. It's a more complex routing protocol. Okay, so the routing redundancy, right? The routing redundancy, it is in the large network, you should have the multiple ISP connection. I think about if you have the large network, right? Instead of rely on only single ISP, you can have more than one connection to ISP, right? So see, if the primary link go down, you still have redundancy here, right? In the large network, you should have a multiple ISP connection with each of the using the geographically separate hardware and network. So two redundancy technique includes the first one is the active redundancy here. Active redundancy, that means both of them running. Right? You think about it, you have network here. Sorry. You have network here. Right? You have one interface to the 1S ISP one here. Right? And you have another interface to the ISP number 2 here. Both of them work. Both of them work. Right? That's why it's called the active redundancy here. The second one is the active passive redundancy. So in the case of the active, this one works, right? This one is the backup here. But something going down, this will be the active here. Right? You have the two redundancy techniques, active and the active passive redundancy here. And you have some of the protocol. Is the first hop redundancy protocol can be provided at a virtual IP address at the default gateway. So we can have the virtual routing redundancy protocol. You have a host standby routing protocol, or you have a gateway load balancing protocol here. All of them, it work with the kind of the redundancy here. Let me show you how it works here. Right? Let me show you let me show you some of the simulation, right, how it works here. Here, this one. I have something like that. Okay, so that is a side that when we work with the redundancy here, right? So see, or from the PCI here, see, in order to go to the web server, you have two ways to go in, right? You can go to the S1 and go to the router 1, and you go to router 2, and you go to the web server here. But if something going down with the router 1 here, or the link going down here, right? You can have from the PC2 here, sorry, PCI here, you can go to the N number 3, and you go to the router 3, and go to the router 1, and go to server here. Right? That is the way you work with the host standby redundancy protocol here. The question, I think I have someone needed a more straightforward here to give it to you, but I don't know where. No, I don't have. Sorry. I can do it again later. On the next class, I can do it. I'll show you how it works. So basically, how it works was this one here. You can think about this one. I think let me give you an example about this one here. Host standby. Sorry. You have the host standby routing protocol here. Think about this one, right? If you have the computer here, so you normally connect to the street, right? You connect to the street here, right? And from the computer, you can have the go to router, from router here, the one here. I think about this one, and go to router 3, and go to internet here. Right? So what happened here? You see, if for this one here, you only have one way to go out, right? You only have one way to go out. That is problem of the single point of failure here. If what happened here, if the router 1 going down, you totally lost the connection to the internet here, right? So in that case here, you can have the redundancy here. You have another router here, router 2 here, right? And in the router 2 also connected to router 3. So see, if router 1 here going down, right? Router 1 here going down, you still have a way to go to the router 2 and go to router 3 and go to the internet here. That's always the code. It's a hot standby routing protocol. And why is it hot? Why hot? That means whenever this one going down, this router here automatically bring it up as active here. So normally in the normal condition here, this one is active, and this one standby. Standby, that means he doesn't carry any traffic. Right? Normally any traffic from the computer here to internet, you always go to router 1 here. You always go to router 1 and go to router 3. But in the case this one going down, this one in automatically bring it up here as a backup, and now he become to standby. Sorry, active here. And that's why they call it a hot and standby routing protocol. Right? And remember this one here. This one here only work with the Cisco device, and this one here it works quite the same with the hot standby routing protocol, but it is neutral vendor. You can work with any vendor here. And the fourth one here is the gateway load balancing protocol. This one a little bit different with this two guy here. This one here actually every router it is active router. Every router is active. See, if you have a 2 router here, both of them are active. So it works, and in the case round robin, right? So see, the first packet here it can route to the router 1, and the second route packet is send it router 2, and the third again send to router 1, and the fourth send it router 2. It's kind of round robin here, right? So for this one here, that's why everyone are active and they work in the load balance. They distributed in the imbalance here. But in that two protocol here, you only have one active and one standby here. This one it can support to the 4 gateway here. In the 4, I'm not really. I forgot it. Now come back to this one here. Come back to this one. You have the problem with this one here, right? So now think about if you have the computer here, you connect it to the street here. Again, you connect to the router 1 and send it to the router 3 here and send it to internet here. And in the case of redundancy, right? You have router 3 here. You send it to router 2 here, and you send it to router 3 and send it internet here. Now, if you look on this one here, right, from the computer point of view here, what do you think? How can you configure the default gateway for this one? Default gateway. How can you configure the default gateway for the computer?
Sorry, I didn't quite catch the question.
Okay. Now, normally when you configure the IP address for the computer, right, you have some information here. You have information about the IP address. You have information about the subject matter. And you have information about the default gateway, right? And the default gateway, where you got the information for the default gateway? Where you got the information for the default gateway in your computer? Router, right? It's always router. It's a route default gateway. It is the way you go out here, right? So basically, see, if you have only one router, right? You think about forget what this. If you only have one router, so the default gateway is always the IP address of the interface here, right? right? Got it or not? So think about this one here. You have 192 here, 168 here, .1 for this one, and you have 192 here, 168 here, .1 for this one here. So see, normally you have to configure, you have to take the IP address of the interface here, and you configure the default gateway for the computer 192 here, 168 here, .1 here. So see what happened here. It's the link going down. It's it's the router here going down. Even that you see, physically you have the backup here, but it's not work because the default gateway here you configure it stick to the router here. So in order to do that, you have to manually configure it. You should have to change it to number 2 here. It makes sense or not? For this one, if you want to work with the internet here, you have to go to computer. You have to manually change it to number 2 here. So in that case, the computer knows that you have to send to the 192.168.102 here.
Need to change the.
It makes sense or not? That this step here makes sense or not?
Yeah.
Oh, okay. Now it's not good way, right? You want to do with the host there, host standby here. That means whenever the router going down, it automatically shift up to this one here. And if you have to do it manually, it's not good at all. It's not good at all. So here's the thing. In order to do that, they group the 2 router here together. They group 2 routers together, and they set that at what is it? They call it here. What is it? Here they use a virtual IP address. They use the virtual IP address, right? So they group them together. They put the IP address here, 192.168.1.100 here. That is virtual IP address. And of course, that's on the so you have to configure the default gateway here is a .100. So see, both of them share the same virtual IP address here. But this one going down here, this guy knows for sure that he has to send it to the router 2 here. That is the way that you have to group them together, and you have to use the virtual IP address. And on the next class, I will do the simulation. I can show you how it works with this one. Right now, it takes time for me to do with the route with the packet chaser here. Okay. So basically, this 2 one here work the same. You only have the one active, and you have one standby. But if active going down, you route it to standby here. And remember that one only work with the Cisco device. This one is neutral here. Can work with any vendor. And this one also, it only work with the Cisco device. But this one here, you have the load balance. So we can group the router together. So the first request you go to router 1, the second request you go to router 2, and third request you go to router 3, and the fourth request you go to router 4 here. They distributed the load balancing here. It makes sense? Clear or not?
I get it, I think.
Okay.
So they change the default gateway using the virtual.
Again, they group them together into the virtual IP address. So it depends. It decides which one to go to this one, or this one, or this one, or this one. Which one? Edge router and your ISP edge router.
Is it C?
Or FPF?
Is it C?
It means OFPF here?
Yeah, OSPF.
Let's see. BGP. Because here you work between the 2 autonomous systems. So whenever you interconnect the 2 autonomous systems here, you have to work with the BGP here. Now, it comes with the WAN connectivity here. The WAN connectivity option includes some of the following options. The first one, broadband. Broadband is a cable and bandwidth are shared between the multiple customers here. You have a share, right? The ISP makes the best efforts. Remember the bad effort here. That means he tries the bad, but not guaranteed. Right? That to attempt to provide to advertise the bandwidth, and bandwidth is asymmetrically. That means you have the download and the upload is not the same. Right? So normally the download it have the higher speed and faster speed, and the upload it have the lower speed here. The second one, you have a dedicated internet access here. So it only reserve it to you and only guarantees the bandwidth, right? That's the throughput here. It's always reserved to you here. And it is a symmetric here because both of the download and upload are the same. So normally it's very important for the business that you need to back up large amount of data online. You see, when you reserve it, that means you only use it. Right? If you don't use it, even that you don't use it, you only have to pay money for that. That's why normally for the companies that you have a lot of traffic going on every time. So you have the digital subscriber line here. You have the DSL, digital subscriber line. It's a WAN connection that operate over the old public telephone network here, public street telephone network. Right? So DSL support or multiple data and voice channel over a single line. It requires repeater for longer distance, right? Because if it's something about the attenuation here, you have to regenerate it and repeat it again. And the distance between the customer and the central office affect to the actual throughput here. So the longer distance, the lower throughput it is, because of attenuation here. And DNS uses advanced data modulation techniques. And DSN connection by use a modulation technique based on amplitude or phase modulation to answer the wave or higher frequency to carry here. So you have a lot of modulation technique. It can be the amplitude, or it can be based on frequency or the phase. So the most simple one is the amplitude, right? So we see if you have anything think about this one, you have everything greater than 0.5 voltage. It is bit number 1, right? Less than 0.5, you have a bit number 0. That is about the amplitude here. And frequency that you have something about very, very high frequency here. You have bit number 1, but a lower frequency, you have number 2 here. Sorry, number 0 here. Okay, you have the type of the DSN vary according to their throughput rate, data modulation techniques, capacity, and distance limitation here. It totally depends on what type, right? Some of them it depends on the distance limitation also. You have some of the DSL here. You have ADSL, asymmetric. It's a faster download speed than the upload speed. And it's a most common, right? Because for the most common here, you expect that you download more than you upload here. It's best used for the video conferencing and web surfing. You have a very high bit rates for DSL, VDSL here. It's a faster than ADSL, also the asymmetric here. And you have the symmetric DSL. You have equal the download and upload speed here, and maximum around about the 2 megabit per second here. You have a cable broadband. Cable broadband is the most common in PC, right? As a home router here. Normally, you can use the old cable television now. It's a coaxial cable. Coaxial cable here. And what else? It can support to up to the 7 megabit per second download and 7 megabit upload here. It can have hybrid fiber coaxial, use a fiber optic cable to connect the cable company distribution center to distribution hub, and then to the optical nodes near the customer here. Everything here is a definition, so I do not go into detail for this one. This one is you have the combination of both of the fiber optical cable and the coaxial cable here. Right? So basically, you need the fiber optical cable for the higher bandwidth and immune to the interference. Right? You know that. Right? And when you come to the customer here, you can convert it to the coaxial cable here, and you deliver it to the home. And you need a cable modem, right? But in the case that you want to convert from any type of the signal to another one here. So if you want to convert from the optical cable to the coaxial cable, you need the modem here. So A cable modem can connect the device at the router to switch. Modem, that means a modulation and demodulation here. What else? Fiber, right? Fiber, nowadays fiber use a lot with the fiber. Back then the fiber is very, very expensive back then, but nowadays the price is going down a lot. So nowadays a lot of customer is able to support for the, is able to work with fiber here. It is you can have the fiber to node or fiber to the neighborhood. It's a nearby service junction that serve a few hundred customers. You have fiber to curb near pole or equipment cabinets that serve for the few customers. You have the fiber to building or fiber to home here. The most common here. The junction box as the demarc to the building, directly to your network here. So we have the fiber to node here. It support for many customer here. Sorry, many customer here. You have the fiber to curb and you have a fiber to building or fiber to home here. That very come to the home here. And you have list line. List line, that means you want to someone is stable. You don't want to share with anyone. And that you have something about guarantee about the bandwidth here. You have dedicated bandwidth. You have symmetric bandwidth, and you have the service level agreement here. You only have to service level agreement back guarantee here. So what is a service level agreement? That means you need to ISP to commit to use that thing about that you always support for for bandwidth of 100 megabit per second here. You cannot let without that. That is kind of the service level agreement. Or the downtime in 1 month only about 1 second or 2 seconds only. That I think about the service level agreement. That's why if you need something about reliable and dedicated, you have to use a list line here, and of course you have to pay more money for this one. And the ongoing monthly cost of the list line, it depends on manufacturer require bandwidth. The more bandwidth you require, you have to pay more money. The distance also. Now you work with a multi-protocol label switching here. MPLS is enable multiple type layer 3 protocol to travel over any one or several connection oriented layer 2 protocol. And MPLS sometimes they call it a 2.5 layer here, because it lay between the layer 2 and layer 3 here. You see, you have the stream label here. You put the stream label between the layer 2 address and the layer 3 address here. Now I think it should be better if you watch the video here. Why?
Atera solves IT problems before they even happen.
Hello, and this is Sunny. Welcome back. Last time we talked about two switching methods, packet switching and circuit switching. Today we will discuss another switching method, multi-protocol label switching, or MPLS. Before we get into technical details, let's see an example showing how an IP packet travels over the internet. Suppose an IP packet is sent from Mumbai, India to Kansas City, Kansas. The destination IP address is 202.35.109.56, for example. I just make up this IP address. As it is delivered over the internet, many routers would be involved in forwarding this packet along the way. It works like this. The first router would open the packet and read its IP address, and then forward the packet to the next router based on its routing protocols. The next router does the same thing. It would open the packet, read the IP address, and then forward the packet to the next router based on routing protocols. Every other router repeats the same process until the packet is delivered to its destination. This is how packet switching method works. Packet switching is flexible and the data path is not fixed, but processing IP information at every single router slows down transmission. Circuit switching method is a fixed path switching method. It is generally used for traditional telephone communications. It is reliable but more expensive. If you want to know more about circuit switching versus packet switching, you can check this video. MPLS, on the other hand, allows IP packets to be forwarded at a layer 2 switching level without being passed up to layer 3, the route.
Okay, so that is a key concept here. Right? You know that if you want to route from the source destination, right, you have to send the router. So whenever you send to the router here, router have to do everything about the encapsulation. Right? He have to open, like accept, he have to accept the layer 2, right? And layer 2 send it up to the layer 3. Layer 3 here, he have to look in the destination IP address. That's the first thing, right? Look in what is the destination IP address. The second one here, you have to look in the routing table. Right? You look on the routing table here, and he have to look and to know what is a way to route to the destination here. I see that the process slow down here. Right? See, you have to look on the layer 3 IP address. You have to send it up layer 3 IP. Layer 3, you have to open it up. You have to look in the destination. You have to look it up in the routing table, and you make the decision to forward it out. Right? You see, slow down process here. But the thing here, if you send it to layer 2 with the MPLS here, if every packet is the same destination, right? User put is the label here. So whenever you see the label, it works at layer 2. Is that route on the same route here?
You don't have to open it.
Yeah, we just send it to the same route here. It have to increase the process here, right? And is and a faster process here. Oh.
Level. Now let's take a look at how MPLS works with the same IP packet being sent from Mumbai, India to Kansas City, Kansas. Making IP packet process is the same, but this time MPLS label is added to the package.
You see, if you send it for multiple packets, right? But all of them have the same IP address here. If you don't have to work with the MPLS, every router have to accept that kind of packet. Do the same process, right? Send it to the layer 3, check the routing table, and send it here. But if you work with the MPLS here, you know that you send it to the same destination, right? You just put the label here. Everyone, you look at the same label, route on the same route here.
If we look at the package inside, here is MPLS label, which includes special addressing information. It is inserted into between layer 2 header and layer 3 header. That's why MPLS label is sometimes called MPLS shim. With MPLS, a predetermined route is established before the IP packet is sent. Along the way, routers only need to interpret the MPLS labels. They never look at the destination IP address until at the final destination. These routers act like switches on a local network. As a result, MPLS offers potentially faster transmission than traditionally packet switching networks. In summary, MPLS can create end-to-end paths that act like circuit-switched connections but deliver layer 3 IP packet. As we know, routing is the layer 3 function, while switching is a layer 2 function. LPLS makes those routers on the internet act like switches on a local network. That's why MPLS is also called 2.5 layer protocol. I hope this video.
I have a question.
Yes.
What if a router on the predetermined route goes down due to a power outage or something?
Yeah, that is a good question. So with that question here, they have the notification. If they place the notification here, you have to set it back to the destination, and the whole process you have to start it from the beginning. You have to figure out what is the alternative path to the destination here. Alright. Okay.
All right, thank you.
Yeah, yeah. Actually, I also think in my mind someone will know that question. That's good. Yeah, that's good. Yeah. Okay, now we move to the cloud connectivity option. Nowadays, you see, you move a lot to the cloud, right? AWS here, Amazon, you have a Google Drive, you have Microsoft, right? You have the Salesforce, Oracle here, a lot of things, right? So you have a lot of benefit with the cloud, right? You don't have to pay upfront for money, right? You don't have to care about the network infrastructure. You just care about the application. We have the software-defined network run here. Software-defined network. That you remember that in every router on the switch, right? Normally they break it down in the two panel here. The first one, they break down in the two panels. The first one, it is data. The second one is the control here. Data is everything about the street, right? You maintain about the MAC address table, right? So we know what port it is. You have to send it to the destination. And for the router, about the routing table here, right? Yeah, how you route it to the destination here. The control information is everything about how you remote access to the router or the street, right? How you work with the FTP spanning tree protocol, right? Everything information about SSH, Telnet, right? That's everything about the control information. How you authenticate it. So basically, for when you work with a software-defined WAN here, they group all the control information together. So you think about we have router here, you have the switch here, you have router here. They break it down in the control information here, and they group all of the control information and they control it centralized in the one server here, in the server. So what happened here? So we see when you go to the router, if you want to configure for the authentication, you have to configure what is the username here and what is the password here. I think about if you have the network of 100 or 1,000 routers, you have to go to every single router, right? You have to manually configure it. Take a lot of time with administration here, right? So instead of that, you maintain the single centralized server here. Right? So whenever you log in the switch or router sends a request to the server here. There is you want to access with the username here and password here, and now you have the database on this one. Right? You can check it here. Now is your name and password correct or not? And if correct, you're able to access to the router. That is, you have the huge benefit with the software defined here. That is a one benefit. And the second one is that see, you can look if you are the user, right? You can go to any switch or router, use the same username and password. You don't have to manually configure every single one here. I see. Now you just look, let's check it on the database here, and database confirm it's correct or not. Also, you do with authentication, authorization also. Authorization is that to each level you can intervene in the network, right? Some of them they only have do some of show command here, limited show command, but some of the users they can change, they can configure everything with the network here. Okay, so sub verify, you can have controller here, you have the SD1 here is a controller, right? Control the direct traffic through the optimal path on the traffic at a given time. You can have this one. And the wireless WAN. So basically you can have the optical cable, you can have the what is it? Copper cable, right? You can have a copper cable, you can have optical cable, or you can have a wireless access also. Right? The wireless access you can have, think about, we have the microwave, we span a long distance here. You can have a satellite, right? And it has a cellular also. You can think about it. Now you have the cellular technology, you have the first generation, second, the third, the fourth, and nowadays you have the fifth generation here. It depends. And nowadays support for 1 gigabit and maximum of the 20 gigabit for upload here. It's a fifth generation. That's the cellular here. And in the cellular, you have the center of it, and you have the mobile switching center here, and you have everything they call it the station here, right? And they have the coverage on coverage here. Satellite also, right? Satellite, you have see a lot of the nowadays you have the GEO here. That means always on the same rotation with the Earth, right? That's why it always look directly to you here. But satellite. What is this? Okay, now you move to the internet connectivity issue. When you lose an internet connectivity, troubleshooting can have to determine the location of the problem and the party responsible for repair the connection here. So think about whenever you have the problem with the internet connection, you have identified it is your network problem or it is an ISP problem here. So that's why you have to understand that which one belong to your responsibility and which one belong to the internet service provider responsibility. Right? That's why you have to go to the entry point. You have to go to the demarc point, and you know which device you have problem with. Okay, so normally you have the sum of the following list. Some of the common issue look on the own equipment here. The interface error. What happened if you have the network interface card? What problem here? What you have the loosen RJ45 connection? That is the most common, right? You have DNS issue also. DNS issue that means you cannot translate from the one web address to the correct IP address here. Right? You have the router misconfiguration, and you have interference also. Router misconfiguration, that means when you configure the wrong default gateway. Right? So see, when you have a wrong default gateway, you have no way to go out. Right? Or you have the wrong routing table. Also, it has problem here. Okay, now interface problem. You have the several command provide insight to device to an interface performance here. You can check the vulnerability and the misconfiguration here. So in the Cisco device, you have a lot of command you can check. You can check here. You have the show running configuration. You have a show interface. Show running configuration give you everything about how we will do the configuration on the router or the switch here. The show interface give you specific information about specific interface. From that you can see how many error packets going on and what is the status of the router or the switch here. Okay, so basically for the switch or router here, If you want to check for any compression, you go with the show running compression here. So you can see you have the information about the name of the router, and you have standard here. You have standard for this one, the IP address, the subnet mask, the IP address, the subnet mask. It works with the rubric here. It is also here. So you have a lot of information with this one. Now, if you want to check for specific interface, you want to check for a specific interface, you have show interface here, and now G0/0. So see, you have standard interface here, up and up, and you have information about the MAC address here, IP address, subnet mask, information about MTU here. Okay, that is something I have mentioned. Maximum transfer unit, maximum transfer unit. That's why when you set the 1500 byte here, right? So for any incoming packet, any incoming packet greater than divided, you have to fragment it. The correct, if greater than, you have to fragment it. That means you have to break it down into smaller one. So think about if you receive the packet of 4,000 here, you have to break it down 1,500 here, 1,500 here, and 1,000 here. Break it down. And you have information about bandwidth here. Bandwidth here. This one is a 1 gigabit, right? And this one you have delay information about the 100 millisecond here. You have some information. You have this one here. This one is it is full duplex and split here. You see. Also, you have the adapter. Yeah, adapter also, connector also, right? But see, you have some information about how many packet input, right? You have information about error here, right? You have information about the error here, right? Frame overrun. Overrun, that means you have very small frame here. So basically, when you work with the frame, it might be in the range from the 64 to 1500 here. The less than 64 byte, they call it the overrun. It's normally a problem of the network interface. If something like that. I see you have everything information about static here. So we see if something going up here, you have to take action to look into the network interface here. And in case of giant, that means you have a packet greater than 1500 here. So normally in the case of giant, that means you have the long cable running. So see, you have a lot of options to troubleshoot the problem here.
Is there any resource that can tell us like what you analyze that if this number is beyond this, there might be this problem?
So I say again.
You just diagnosed it, like you said, it's the interface, the data is beyond 100, then must be the interface have some problem.
Yeah.
Is there any?
If the cable is very long, right? Very long, yeah, you have some problem with the giant message here.
Okay.
Yes, so see, you have the information, right? How many error, collision, sorry, the collision here. Collision is the most common problem when you have the long cable. The long cable, that is a collision.
Like a doctor. Like a doctor diagnose the patient.
Okay, and in the case that you want to check how to know how to route to the destination with the command here, show IP route. So it will tell you that in order to route to this network, you have to route it out this interface. This network here, you have to route it out this interface here. That is command you have to show IP route here. So some of the common routing issue, it can be the missing route. So see, if you look on the routing here, so now if I think about this one, if I want to send it to the 10.10.10.10, I have no way to do it. Because here you have no information about this route. So that is will be so I said that is a presumptionally, okay, of course you don't have the network here, but at least if you want to route the destination must show up in the routing table. Or routing loop is that in the case you work with a distance what is it? Distance vector, right? Distance vector here. You have no idea of the overview of the topology. You just ping pong it again and again together, right? Okay, that asymmetric routing, that means you are not they are not the same from the both of the end here. Now the routing, yeah, you can check by the IP route here. So see, if you want to send it to a network here, if you have information in the routing table, you can do it, but not here. Definitely, the packet will be dropped by the router. So in that lesson, I should be able to identify the fundamental element of the WAN service option, explains how router manage inter-network communication, compare and contrast the WAN connectivity technology, explain the most common wireless WAN technology, and troubleshoot some of the common connection problem here. Any question? Guys? So basically, right? So basically, if you have the complaint about if you are the network technician or network administrator here, you got the complaint that he or she said that I'm not able to connect to internet. He said that, right? So what do you think? What is some step here you have to do? You got a phone call and that complaint that I'm not able to connect to the internet. What is some action here? What do you think?
Check the router,
Huh?
check the router, check the interface.
Yeah, you have the step to do it, right? Now, what do you think? What is the first step to do it?
Check the cable and
Yeah, right. You always have to go from the lower layer. Right? The first thing you have to check the cable here. If the RJ45 got loosened or not, right? That's the thing.
then go to layer 2.
Okay, so what is the next step? What do you think? The first thing is check the cable here. What do you think? What is the next step?
So layer 2, let's change the router and the interface is working or not.
Right. Now see, if you have the computer here, right? If you have computer, the thing you have to
layer by layer.
You have the computer here, right? So basically that you connect it to the street, right? The street here, and from the street you connect to the router at the gateway, right? From router you connect it to the internet service point. So basically, in order to troubleshoot it, you only have to contain everything inside the network. Otherwise, you have to escalate it to the ISP. So see, the first step here, check if the cable here plug in or not. Plug in or not, or get loosened or not. The next step here, you have to make sure that the network interface card here work perfectly or not. And in order to do that, you can test by the loopback here. Loopback address. Loopback address. That means you can bring to the 137.0.0.1. That is the IP address of your network interface card. And so exactly check about the stack of the OS. What is it? TCP/IP. Sorry, TCP/IP stack here to make sure the TCP/IP stack work or not. Now you bring to the 127.0.0.1. It works perfectly. You have no problem with this one. Now you have to check. You have to check here if you are able to bring the default gateway or not. Because here, whenever you want to go to internet, you have the first step here. You have to go to the default gateway. So now you have to bring the default gateway 192 here, 168 here, .1.1. You are able to connect it or not. Yeah. So something here. Something about even that you are able to bring to the default gateway. Sometimes that you see when you have entered the World Wide Web, right? Cisco.com. You are not able to route to the Cisco.com. In that case, you have to check for DNS information. DNS information. Because you have to send request to the DNS server, and server send it back to the IP address here. So you have a lot of the steps to do it. Some of the basic steps here. Okay. So any question for the today class? Let me know. Any question?
I'm okay.
No question. Let's see what we have here. Okay. So for this one, need to work with the pin command here, the pin command, and for the pin, so whenever you, so basically for the pin command, you see you have the pin extend. So see in the pin extend, you have a lot of options. Right? You see you can have the you can pin to the specific port until stop. So normally you send about 4 packets only, right? But in the case if you want to troubleshoot here, you want to ping it forever until you narrow down problem here. Right? You see, you can ping it until
control state.
yeah. You want to stop here. So if you want to stop, you can do the control break or the control C here. Right? You have early here to resolve the address host name and count here the number of the request. Right? You have F, that means you tell the router do not fragment here. Do not fragment here. Right? And you have I, that is specify what is the time to live. You have the time survey. You have record. You have a lot of options with the thing here. I so think about this one here. I think Cisco.com. Now for this one here, I want to print for 100 times. Right? So I have and here. I put 100 here. Why am I not able?
It automatically shows the IP of the Cisco account. Is that means the DNS server is working properly?
Yes. Why am I not able to? Oh, sorry. I put the wrong Cisco. Yeah, right. So it do it for 100 times. Do it for 100 times, and if I want to break it, stop it, I control break it. Okay, so you see, you have a lot of options with this one. Yeah, you can set what is it? Set the buffer size. Now come back to this one. So what is the app here? You see what is the app for this one? App here, that means tell the computer here, right? Do not fragment. Do not fragment. That means even that is a fragment is very large. Do not break it down. Right? Do not break it down for this one. So the first one is the F, that means do not fragment. The L here, that is the size of the frame. Right? So for 1024 here, it's okay. 1024 increases 1000. Sorry, 1248 here, you know, okay. Now you increase the 1396, you know, okay. Okay. Now that kit increases. So at the point when you see the thing is that here. The thing here is that when you set the flag here, when you set the flag at, that means tell the computer here do not bracket. Right? So even that he send the packet of the 4000 here, it keeps the same. It not break it out here. So the flag here F do not bracket. Right? So you see the purpose of this one is observe what is the maximum minimum. So at what point you got the fail? Because if you don't break it down, you have no way to judge it here. Right? Yeah, that's the point here. So we see
it's the limit.
Yeah, what is the limit? That's the purpose of this one. So I think this one is very simple. When you Right, you see, this one not able to do it. You have to reduce here. Increase it here, and so on. You have to do it and observe it. What is the MTU for this one? What is it? This one, I think it's split there. Okay, so actually they already have the split that here, right? So this one very simple. You just click and observe what is the download speed and what is the upload speed. Remote set. This one is this one. How to do the remote desktop access. So I think this is not problem. You just follow the instruction here. Not the problem with this one. This one, not much work with the this one. Sandbox. Okay, so I think that's all for today. Let me check the attendance here. Mark, are you here? Mark, not here. Tyler,
Yeah, I'm here.
Daniel, are you here?
He's on the Zoom.
Ali, are you here?
Yeah, I'm here.
Matthew,
Present.
Jack,
Yes, sir, I'm here.
Thomas, are you here? No. Okay, so I see you guys on Monday. Okay, and time to do the homework or assignment, and if anything come up, you can send me the email or you can join my office hour. Do not wait until the last minute. Okay, bye guys.
All right. Thank you for your time. See you Monday.
Mhm.